Hello, music appreciation students, and welcome to our third element, melody. Melody, one of the most easily recognizable of our elements, I believe, compared to harmony that we will be learning about next time. But melody is something that's all around us. Melody is something that we can all grasp rather easily once we know exactly what we're listening for, okay? Um, Melody is essentially the linear or the horizontal presentation of pitch. So it's like a line that goes up, it goes down, it can do all sorts of things. It can be an arch shape, it can be a wave, it can be an inverted arch, whatever the spirit so decides to do when they're writing a melody. Okay? Basically speaking, though, a melody is the tune. Okay? It's the tune that people can sing along with. Say, for instance, if you're a big fan of the song Old Town Road, the melody, oh, my clock's chiming again. The melody would be the part that you sing along with, okay? So when the guy comes in singing or rapping, you are going to copy the melody. You're not going to sing the harmony. You're not going to sing the bass line or anything like that, okay? So it is the melody. Now, in rap music, melody can be a little bit harder to wrap your head around because there's so much spoken dialogue, but that rapidly spoken dialogue is still melodic. Basic pop music is a little bit easier to pick up the melody, okay? And the melody, much like harmony too, but right now we're living in a melodic world, is made up of pitches. So pitch refers to the relative position of a musical sound, okay? So that basically means when you hear it, is the pitch high? Is the pitch low? Is it kind of in the middle? Is it easy to sing along with? Is it not so easy to sing along with? Do you feel like you're having to stretch to reach it? Or do you feel like you have to push down low to reach it? Those are things to think of when you're thinking about pitch. And basically, pitch is based on the vibrations per second or the frequency of a sound. Okay, so pitch is a scientific phenomenon. Pitch actually is measurable. Okay, now what we consider to be the acceptable pitch, now that is up for debate. But there are actual sound waves at play when we're talking about pitch. In the Western tradition, we identify our pitch by letter names. And they're basically the first 7 letters of the alphabet. So A, B, C, D, E, F, and G. Okay? That is our musical alphabet. Just those 7 letters. Nothing more. All right, so let's talk about pitches and scales. So here's a little Mozart meme for you. I gave that pitch a note. Pitches love notes. Ba-da-cha. So pitch. Pitch is a twofold phenomenon, made up of the actual frequency of a tone and its relative position in a musical scale. So the tone or the note is what you hear. The tone is what you hear. The note is what you read, okay? So tone is the actual oral impression, okay? So the tone of a C has a very distinct sound that we have been taught to identify as a pitch. And then if you're a musician and you can read musical notation, somebody puts a piece of music in front of you, musical notation, more properly, you can identify what and translate what that notation says to a piano or to whatever instrument, okay? And I say, if you go up to a piano and you pick a key on the piano and press it, you've played a pitch, okay? The piano has 88 pitches. There are 88 keys. Now, of course, there are some repeated pitches at intervallic octave intervals, and we'll talk about that more in just a moment. All right, so here's a little bit of science, how you hear sound. You can read all this, but generally pay attention to these things right here. Amplitude is the height of the wave, so the higher the amplitude, the louder the sound, the lower the amplitude, the quieter the sound, okay? Then we have wavelength. So the wavelength will indicate the distance between the crest and how close these 2 points are close to each other. Okay? And then we have the frequency. The higher the frequency, the higher the pitch. The lower the frequency, the lower the pitch. All right, carrying on my wayward son here. So here's what a sound wave looks like. and you can see what one cycle looks like. It's from, so it's basically a sine wave, right? So if you are a math person, here's your math coming at you with the sine wave, okay? So this all works together to create sound. Um, Unfortunately, this video won't play on here because it's just an image, but it is in the slideshow that I give you guys in the resources. So do watch this video because I find it really helpful to help you understand the basics of sound. All right, now pitches. I put pitches, keep on moving. In our Western tradition, we have 12 distinct pitches that repeat at octave intervals. Okay, so we use our 7-letter alphabet, and I can hear you saying, but you said there are just 7 letters. Well, there are. There are just 7 letters, but we use different descriptors on those 7 letters to help us out, okay? So what I mean by that is if you look at a piano keyboard and you find A, there's an A sharp, or it's also a B flat. This is what we call an enharmonic. And then, so A is a white key, A sharp, B flat is a black key, B is a white key, C is a white key, and then there's a black key by C, which would be C sharp or D flat, then D is a white key, then there's another sharp or flat key for D sharp, E flat, then E is a white key, F is a white key, there's a sharp flat between F and G, there's a sharp flat between G and A, and there's a sharp flat, here we are back at A, right? So here's our alphabet, A, B, C, D, E, F, G, okay? And then we've repeated A at the octave, okay? And then, so there's 7 letters, 8, 9, 10, 11, 12, when we include the half steps, okay? So that is our musical alphabet, and that's how we get 12 distinct pitches. Okay, in our Western culture, we tune A to 440 hertz. So A440 is A5. It's the A closest to middle C, or the A above middle C. That's 440 hertz. So this 12-pitch system is known as equal temperament. Okay, so this became very popular in the Baroque period. Okay, Bach didn't develop equal temperament, but he was one of the main experimenters with equal temperament, and he helped to show that equal temperament could work. Today, we don't even think about it. But what it essentially means is that everything that we listen to today is actually a little bit out of tune because keys used to have distinct sounds. So the key of C had one sound, the key of G had another sound, and composers were able to use that. And some composers still do use that. Where we begin to have problems with it is when we use instruments that just have to be tuned and stay tuned, like pianos. Piano, you can't easily adjust the tuning on a piano. It's a process. Same thing with an organ. So they are the instruments that are mainly equal-tempered tuned. If you listen to a choir perform without one of these instruments, or an orchestra perform without an instrument that has a mandatory tuning, you'll hear more of a representation of the actual keys. Okay, but you don't need to know all that. And there are more than 12 pitches out there that exist, but we just, in our Western culture, recognize the 12, okay? And we use this pitch system, numbering system. Music is math, and so we use this system a lot where C equals 0 all the way up to B natural is 11. And we can do all sorts of mathematical equations to create music. It's really fascinating when you get into the study of it. Okay? And I love to say, too, that every song you've ever heard is made up of those 12 pitches. It's incredible how 12 pitches and the rhythms and everything that are possible out there create every song you've ever heard. Okay? Now, pitches are constructed mathematically. And by that I mean we can divide them into further subdivisions, we can double them, we can do other sorts of mathematical manipulations to them to create our scales, okay? So I give you a little bit of a guideline here as how the octave happens. So an octave is the doubling or the halving of a frequency. And then what happens in between them is another mathematical phenomenon, and we learned about that with our our ancient history Greek gentleman. So I have this awful screenshot of this video. I apologize, but this lady here is an overtone singer, and I really would like for you to watch this video because it is really interesting what she is able to accomplish singing a fundamental pitch and then eliciting the overtone series over it. Okay, and then there's a physics video that you can watch. Now, pitch is an essential component of music. Okay, I ask you, what are other essential components? What do you think has to exist in order for music to exist? And then I reiterate the point. Every song you've ever heard is made up of those 12 pitches. Okay? We're going to stop here for this video. We're going to pick up with pitches have relationships, and that'll be in part 2 of this. Hope this is making sense and that you're feeling pretty comfortable with what pitch is. Make sure that you are watching the videos and everything for this class. That'll really help you with your understanding. So I'll be back with part 2 momentarily. Bye.